Welcome, I'm Jonathan Vennard, Associate Professor of Precision Machining here at Vincennes University. In this video, we will establish the Z offset for our lathe part. Our Z offset establishes the Z axis origin along the length of the workpiece. This enables each tool to understand where the end of our material is. We have to teach the machine these positions during our initial setup. To do that, we're going to manually face down the part and establish a datum surface on the end of the part. And we're going to store that as a work offset in the control. We'll start in manual mode, in manual setup, and set our RPM. Now I've got the RPM set at 1000 RPM, which is a fairly common RPM, and I've got my jog feed rate set to 10 inches per minute, which is nice and slow, so I'll get a good surface finish on my datum surface. Now, I'll go ahead and turn on the spindle, and then hand feed over to the part. I'll come over in Z, then I'll come down in X. As I get down below the edge of the part, I'll move in the Z negative direction, but doing so very slowly. When we see it start cutting and making a chip, we can begin moving out in the positive X direction. At this point, I will move 2 clicks in the negative Z direction, which is 20 thousandths of an inch. Now, using the manual feed rate plus minus buttons, I will feed down the part at our 10 inch per minute feed rate, manually facing this datum surface of our workpiece. Then, I'll move away from the cleaned up datum surface in the X direction and turn off the spindle. We can open the door now to inspect our part, make sure that it's cleaned up entirely. With this surface cleaned up, we have established our datum Z offset and can store this position in the control. So now with tool 1 in the active position, we will use it as our zero calibration tool. Go into part setup and find the offset that we want to store. Now we're not setting the X offset right now, so we need to make sure that we are in the Z offset field. We can store this position as our Z offset, and it will be stored as an inch measurement. So what that's saying is the positive distance from the face of the spindle, which is behind the chuck, to the face of the turret. All other tools' Z offsets will be a positive or negative value based on how they relate to tool number 1's Z calibration tool. Everything is calibrated so that the distance can be checked just by measuring with the tape measure to verify it. At this point, we can set up the Z geometry offsets for all of the other tools. I typically use a scale. Some people choose to use touch-off paper. As the Z calibration tool, tool number 1's geometry Z offset should always remain 0, but all of the other tools will have a Z geometry offset telling them where the turret position is when touched off the face of the datum surface we have established. Now that's how we set Z offsets and establish the Z calibration tool. To learn more, look for our other videos on CNC mill and lathe techniques.